Hey guys, in this lesson we're going to review how to work with literal equations. A literal equation is an equation with multiple variables. So for example, here you have an equation 2x minus 5 equals 13, and here you have a very similar equation ax minus b equals c. So what I've done here is I've solved 2x minus 5 equals 13. And we solve that, as you know, by adding 5 to both sides and then dividing by 2 on both sides. So it takes 2 steps to get x alone. And x is equal to 9. Well, if you look over here at the literal equation, it's also going to take us 2 steps. But the difference is that we can't simplify completely because of all these letters. So we're going to add b to both sides. Again, we're trying to get x by itself. We're going to add b to both sides. So that gets us ax is equal to b plus c. And now, one more step to get x alone. We're going to divide by a on both sides to get us that x is equal to c plus b over a. So if you compare these two, they're very similar in that both use the inverse operations to isolate. We added both sides, and then we divided both sides. But the difference is the fact that the literal equation, this one right here, will not simplify nicely like this one did, simplified nicely to 19. It just won't simplify nicely because of the multiple variables. No biggie. So this is called solving a literal equation. When you take an equation and you just inverse operation it out to shift it around so that instead of being c equals blah, 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 it becomes x equals blah, blah, blah. And the reason why we chose x is because it told us solve each of the equations below for x. So here we have area equals, or A equals, length times width, or L times W, and we're being asked to solve for W. So solving for W means isolate W. So instead of dividing by W on both sides, we're going to divide by L on both sides because we want to get W by itself. So we divide by L on both sides to give us that W is equal to A over L. And now we've solved for W. In number 5, V is equal to L times W times H, and we need to solve for H. So I've highlighted H. And since H is being multiplied by L times W, I'm going to divide by L times W. And that gets me V over LW, is equal to H. And we have now solved for H. If we hop over to number 6, we look at the formula for the area of a circle. You may not have remembered that that's the area of a circle, but that's okay. We're looking at this equation, this literal equation A equals pi r squared. And we're being tasked to solve for r. So the first thing you want to do, well, first you'll notice that r is being squared, but we'll handle that part last. Let's go ahead and take off that pi first by dividing by pi on both sides. So we have that a over pi is equal to r squared. Now to isolate that r, to get just r and not r squared, we want to take the square root. Okay? So that looks like this, taking the square root on both sides. Why did we do that? Well, we did that because the square root of r squared is equal to r. The inverse of squaring is taking the square root. Kind of like the inverse of multiplying was division, or is division. The inverse of squaring is taking the square root. So we know that the square root of r squared is equal to r. You might want to, take note of that. And that's equal to big square root of a over pi. So now we have taken this equation and manipulated it and solved for r. On the next page, we're working with literal equations that have more than one step to isolate the variable. So in this equation, a equals 1/2 bh, we need to solve or isolate h. So there are a couple values in front of the h, and we're going to isolate them one at a time. First, we're going to multiply by 2 to remove the multiplier of 1/2. That gets us 2a is equal to bh. Again, you're trying to get h by itself, so we can divide by b on both sides, and that gives us 2a over b is equal to h. Number 11, we are solving for m. So I want to remove this division of 2 by multiplying by 2 on both sides. 2k is now equal to mv squared. Keep in mind, again, we're trying to get m by itself. So I'm going to divide by v squared on both sides. And 2k over v squared is equal to m. We have isolated, solved for m. In this next example, we are being asked to isolate w on the equation p equals 2l plus 2w. So since 2l is furthest away from the w, we're going to remove that first, and 2l is adding to the 2w, so the inverse of addition is subtraction. P minus 2l is equal to 2w, and then I'm going to divide by 2 on both sides. P minus 2l over 2 is equal to w. You cannot reduce this 2 with this 2 because you just can't, and we'll talk a lot about that later on when we hit rational expressions, so just trust me right now that these 2's do not reduce, mainly because this one doesn't have a 2. They either all have it or they don't, okay? And now we have just leave it alone and solved for w. The last example I'd like to do is number 18. We have the equation a equals 1/2 times h multiplying to b1 plus b2, and we're solving for b1. Every time you have an outside distributor or an outside multiplier, you want to get rid of this first. So we're going to get rid of it by multiplying by the reciprocal of 2, which makes 2a is equal to, these will cancel, h times b sub 1 plus b sub 2. Just again, we're trying to get this one alone. We still have an outside distributor, so let's get rid of that and divide that off. So we've divided that h off, and 2a over h is equal to b1 plus b2. And last but not least, we are going to subtract by b sub 2 on both sides. So this fraction is going to subtract with b sub 2, so 2a over h minus b sub 2 is b sub 1. So this one had 3 steps to get b sub 1 by itself. The steps were multiplying by 2, divide by h, and then subtract b sub 2. So multiplying by 2, divide by h, and then subtract that by b sub 2. If you have any questions, please feel free to reach out at any time. Thanks for watching.